Yeah. So thank you everyone for giving me this opportunity to speak about very interesting and important topic of present time. Okay, so that is, as you see in that urban heat island is a very common pattern we can observe in many cities, and mostly if you found over the country like India, Bangladesh, and Pakistan. So these type of regions where there is a most of the time we found not a proper planned way the city is actually growth. So there the effect is very huge. Okay, so that's what we are this particular studies we are based over the one Indian cities over the Bangalore. So that we what we will going to discuss in detail for this particular analysis. Okay, so now if you see uh, so very first we have to understand like what is the scenario of urban heat island, so how it is actually affecting. Okay, so if you see urban heat islands, basically what we feel like, if you concentrate over the city and the surroundings, you will found the inside city the temperature will be more high. Okay, so than the surroundings which we found, and these scenarios are more visible and clear over the nighttime. If you focus over the nighttime, so then this type of scenario is will be more visible on this particular city areas. Okay, so for this kind of studies, we are trying to do a different kind of data for the analysis. But a major part of this is the satellite data, the thermal satellites. From there, we are basically use the land surface temperature, which is a very important parameter for the climate studies. And remote sensing technology, you can see, which is estimating the LST, and there is a few meteorological parameters also we are considering, and we estimate the heat fluxes. Okay, which is very important parameters. These two are very important parameter for you can say the urban heat island studies. Okay, for the you can say there's a negative impact or means always is there for urban heat island. Okay, like it is moderate rate is actually increasing because of this urban heat island. Okay, the stress, and it is not only affecting the atmospheric effect, like so many studies which you have already found, like how the urban heat island is actually affecting the atmosphere, but it is also affecting the underground ecosystems. Okay, the subsurface also the heat is actually affecting. So that is the main key focus of this particular studies also, like how much it is actually affecting in underground also. So the remote sensing data is a very useful things for this kind of studies. As we've seen, like we have very good data sets. Okay, like the Landsat is one of the good data for thermal studies, but as we have constraint of the resolutions always. Okay, so it's a 30-meter resolutions. It is a quite good data, but still you will found there is a kind of more, if you get the high resolution images, then it will be more good for this particular studies, what I feel in this. But as of now, we are focusing over the few available satellites. Okay, so that we will going to discuss very soon. Okay, so before that, the first you have to understand the problems. What types of problems on these particular Asians and in South Asians current means cities which we are mainly observe. Okay, so but the first thing is that urban areas are high temperature than the surrounding in the countries. Okay, due to the basically the buildings. Okay, the concrete buildings and the building materials. So there is a specific kind of building materials which you observe, like asphalt, concrete. Okay, and then this type of materials which will be not only the emissions will be more on those type of materials, and yeah, and this type of few materials like asphalts. Okay, so this will be heated in a both time, like both in a day and night, both times it will be high emissions over this type of materials. So this type of materials and buildings which we found more on the in this particular cities which we are focused here as a Bangalore. Okay, but I worked with many other cities in India, so like Kolkata, Delhi, and the scenario is almost similarly same. Okay, so now the increasing this heat, which is known as urban heat island, which is a discomfort. Okay, like basically requires more energy. Okay, for the cooling and increasing the pollutant and directly impacting on this particular human health. Okay, so that's why this is a very serious problem, which we have to study more to understand the particular city conditions according to this particular parameters, how much it is affecting the environment. So if you see now why it is more important, because the urban areas are growing so fast. Okay, so if you see by 70% of the increment, if you found by 2030, which is a leading growth in the largely on urban agglomerations. So most of the people, if you found, they're trying to concentrate in urban areas. Okay, so that's why huge pressures on urban area. Okay, where over the population. So population is a very important factor for this particular kind of scenario if you find over there. Okay, now the urban area strained is basically it's a dark surfaces. Okay, so that is which is increasing on this particular area more. Okay, basically if you see there is a roads or some which is based on the asphalts, and they have the more emissions from the roads. Okay, so because these are dark structures, and it is absorb the you can say the albedos. Okay, so that is more means this kind of materials you will feel there is more types of emissions which you found over the day and night scenarios. Okay, now for this what we require a proper planning. Okay, to control this particular temperature. Okay, to make the urban environment more suitable for the living. So for that we require in detail studies. Okay, so which is more important for, so that is our main problem definitions which we found before we start this research. Now some we will discuss some motivations behind this particular research which we did, like so see here, in most of the metropolitan cities, what we found, there is some particular zones which will be there, the buildings and which will be very congested. Okay, so that is required a government assistance. Okay, to understand about the scenario. So that is one of the motivation to understand the heat pocket. What are the heat pockets over the cities? Okay, so that is the one of the main motivations to understand from these particular studies. Then urban heat island is basically increase the northern signs. Okay, and the durations of the heat waves are also basically increased in urban areas, mostly in Indian cities. Okay, so earlier whatever the heat waves we are faced this in particularly in this particular summer season, now the rate of the heat waves are increasing. Okay, so that is the another trend we found out. Then the nighttime effect, which is very important. Okay, which is particularly harmful during the heat waves, and as it is differs from the urban inhabitants for the cooling relief found in the rural areas, as it is a very common nowadays in Indian scenarios. Now urban populations are also increased, and due to the urban population are increase, so there is a not properly planned way the city is actually growing. Okay, so that is another motivation to understand the you can say the planned areas and unplanned areas. If you compare the city temperature difference, it's a huge differences which will coming out. The area which is more planned, okay, so those are areas are kind of means cool pockets inside the cities. And but if you see the areas where the concentrates of the buildings are more and it is more unplanned, so the temperature is very high on those locations. Okay, so that's what we found as taking us a consideration for this particular study. Why it is in Bangalore, it is very important to understand. See, Bangalore is a city in India which has grown very fast in last 10 years. Okay, so if you, now I will show you the changes in the land means Bangalore. Okay, so you will understand how much big area it was changed, because it is because of the booming of the industrial part of there, like different types of industries like biotechnology, aerospace, and so many other industries actually form in this particular, because it is called as the Indian Silicon Valley. Okay, so due to that reason, but the thing is, it is very much loses of vegetations because of this huge increment of built up. Okay, and which is actually affecting a lot of the urban the main causes of the urban heat island, which we'll found out from this particular study. So the research is being conducted to estimate the surface temperature, which we will try to understand, and then we will also try to go for more detailed studies in urban heat fluxes, okay, and influence. We will try, this is a kind of a first level of studies in India, which we did. We try to understand, like, is there is any kind of effect we will found in the groundwater or not. Okay, so that is what our main motivation from this particular study. Now, the objectives which we focused over here, like we given a three major objectives for this particular study. One is the land use land cover change and how it is going to impact over the surface temperature as well as the groundwater temperature. Okay, so we will try, see, for land surface temperature, we did so many studies from the urban land use land cover. So is there is any kind of relationships which will found out from the groundwater temperature. So that is our first motivations, one of the important motivation. And then another important things which will understand the study, that is the temporal changes and the seasonal changes, okay, variations in the both in LST and the anthropogenic heat fluxes. Okay, so that is also very important part of this particular study. And then study the relationships between the LST and GWT and anthropogenic heat fluxes, which you found any kind of important effect, or you can say the relations we will found it or not. So that is our main objective of the study. So let's discuss the results. Okay, so before that, I will just give you some idea about the methodology we found. It is a part of a big project, so there is some specific methodology which we'll going to discuss. So this is what the Bangalore city, if you see this India, and this Karnataka is a very big state in India, and within that there is a small part. Okay, so this is a small part. We should see this Bangalore city. Okay, so this is, I clip out exactly with the Bangalore, but I will show you the what is the exact growth of the Bangalore from the projected boundary to the present scenarios. Okay, so that we will going to explain you. So before that, you have to understand the city scenarios. Like every cities have unique in kind of Indian some continent. Okay, so you will see there is a different cities are fall under different climatic scenarios. Okay, and Bangalore situation is very unique. Like we usually more interested to go in a Bangalore. Why? Because their weather is very calm. See, if you concentrate the other cities like Mumbai, Delhi, and Kolkata, so it's a very warm temperature in earlier. But if you concentrate in Bangalore, as it is situated in a plateau areas, okay, so that's why so height of the Bangalore is more, height means more basically the altitude from the main sea level. It is a more higher than other cities. Okay, so there the temperature is very cool. Okay, so that is what usually we found the scenario than the any other cities. Well, it is important to understand, like if you consider there usually the temperature which will be, you see, the 35 degree, and the low temperature will come to the 15 degree. See, it's not coming very low in a winter, and not in a very hot in the summer season. So that is what the scenario was there in the Bangalore if you consider 10 to 15 years back. Okay. Now, there is important thing which we try to understand from this particular study. Okay, so that is the main focus is over the data types. What are the different data types we are actually used? Okay, so it's a, as I told you, it is a part of a big project, which is different types of sensor data sets which you are actually using. But as particular this particular study which we did, we used Landsat data sets. Okay, it's a thermal data set, and we use the MODIS data sets also. MODIS is very useful for not only the spatio-temporal changes for a long time, as well as it is very useful for day and night studies also. Okay, so and there is another data sets which we collected, that is the groundwater temperature data. So using the data logger, okay, so these are the different borehole locations around the Bangalore cities. Okay, so where we collected the GWT, okay, means basically groundwater temperature, and there is another parameters also for the groundwater which we collected, but this is our focus is over here as a groundwater temperature. Okay, so these are the main data which we are actually used for this particular study. Now, the first part is this part, which I marked this as a red. As I told you, this is the first part which we are actually our focused in this particular study. Okay, you see, we use the Landsat in a different types of data sets, like 1999, 2009, 17, 18, which is basically the December and January. So that's why the 18 data sets also used. And now there is another part where we collected the groundwater data sets also, as you've seen here. So we collected the groundwater data sets also. So now this is what we are trying to estimate. So one part, obviously, we did the analysis of the LULC changes, okay, land use land cover change analysis, which we try to understand how the land use is changed so fast in the Bangalore in last 10 years, and how it will going to affect over the LST. So that is the one part. This is second part, sorry. And then third part is the heat flux estimations. So from the heat fluxes, how we can separate out the anthropogenetic heat flux, okay, to understand the scenario. Okay, so that is, and then we will try to compare this particular results to understand which land cover is more affected on this particular areas. And that same kind of scenario we'll try to comparison with our GWT data sets. Okay, so now this is the scenario. Okay, so if you concentrate over the last 10, 20 years, if you see like 1999, see almost 2019, which we did the study, so that you see the 1999, this is the city condition. So this is the extended boundary as we found, because this is the extended boundary of the Bangalore. Okay, it's called a project. What is called as a master plan boundary was there. Okay, for the Bangalore, and this is a condition in 1999. And what we did, we just classified, we are in a four group, like built up, water, agriculture, and the vegetation. Okay, so this is our main classifications which we targeted for this particular study. And here we found a significant growth in the built up. So which will be very clear from this particular image we can find. And see, there is a huge amount of area which was there as a agriculture, as a water body, as a vegetation. So water body is mainly the lakes. Okay, and that is a hugely affected by this huge increment in the built up. And that's the is basically affect a massive global, you can say, the impact over the city. Okay, as a huge amount of greenery and the water body is also reduced. Okay, like we will show you in the next slide so that you can understand the statistics, how it is actually changed. Okay, so this is a study which you found. If you see, there's a built up. It's a huge, like from 7.6 to it is increase is to 25.5%. So it's a huge increment in the built up, and it is significantly reduced not only the agricultural land and the plantations area. Okay, so these two are also reduced, but there is a very important thing, that is the water bodies. What we found, like almost near to 400, we have different lakes was in Bangalore. Okay, and that lakes was come down almost 200. Okay, so that is what is a huge effect. But this may be a small pond or wetland areas, those are actually converted in a construction buildings. Okay, so that is how we found out a significant reduce in a water body, we found it here. Okay, so that is from the statistics which is come out. So this is a first level of the land use based studies which we come out. Okay, and when we focused more over the studies, we will try to do some field survey to understand the huge effect area. So there is a few image which we will taken out. Okay, so which we'll seen, we understand. So this is the lake areas. Okay, and this is, you see the lake old channels. Okay, so it is for what is almost 20 years back. This is the scenario, and this is what the water is actually passing on this particular areas. This is basically the area of the Darshathali. Okay, so there's a two area which we found a huge growth. One is the northeastern part and the southeastern part of the buildup. Okay, so these two areas basically, as you see, this all the lakes which is found over near to that southeastern part and the northeastern few areas. And these areas is a completely covered by the buildup in the present scenario. Okay, so that is one of the huge observation. This is one observation I'm telling. So there is a many parts, mostly in the northeast and the southeastern part of the city, we found this kind of similar scenarios. Inside city there is not much change, but the extended area is changing. Okay, is a huge. So North Bangalore is developed with the establishment with the new international airports. So due to that, there is a new, you can say, those built-ups which is coming out. Okay, and like that, there is all the, you can say, the city. There is a new planning and projects which is coming out, or some cases there is a huge effect of the IT sector booming on. So those areas like ITPL and Whitefield, okay, Bangalore, where this PNR industrial area. So these areas are huge growth. okay, over the built-ups which we found out. Okay, so this effect, so if you see, it is a significant change in the land uncover, which is expanding expenses of the deforestations and conversions of the agriculture and the plantations lands. Okay, and some cases it is the water bodies, like lake also. Okay, now, so we start the first level analysis with the LST, so land surface temperature. We will try to understand from the 1999 scenario, and we will try to do it in a both time period. Like sessionally, we will cover the summer and winter. Okay, so usually in India, we concentrate the summer season, which is starting from April, May. It's like that. March, you can say it will be starting from the March, April, May, June. Okay, so this is, we concentrate over the summer. Okay, so, and you can say the winter we are concentrating over, like you can start from the November, December and January. So these are the months we will concentrate over, usually over the winter. Okay, and the scenarios, if you found over the both the summer and winter, so inside the city the temperature is always very high, but there is a significant of the April, if you concentrate on the April LST, so you will found surrounding also very high. This is just because of that time there is agricultural land is basically the fallow land, so it is affecting a very high temperature as a surrounding. Okay, so that is the reason if it will be like that. Okay, the scenarios of those months where there is no agriculture, so those are also areas also coming is a very high temperature. But obviously if we concentrate of the built up, the temperature which is coming more high than any other parameters. Okay, just like built up, it is coming for 37. Okay, so it is increased, is huge. Okay, so this is from 2018 to okay, so 1999. So this is how the temperature LST is actually changed huge on this particular place. Now, to validate our results, okay, so what we did, we the same time when the satellite was passed, so accordingly we planned and we collect the field data sets also, means using the infrared thermometer we collect the LST value of this both locations, and we will try to validate our results which we'll get, and we found a significant match with the ground data with the LST what we found. Okay, so that is basically kind of a validations which we did our work. Now the next level study what we did, that is, as we discuss in our objectives, that is the heat fluxes. Okay, so heat fluxes, what is basically the equations is basically, if you see this Rn, basically your net radiations. So net radiations is basically the combinations of your ground heat, latent heat and the sensible heat fluxes. Okay, so usually what it will be, so whatever the equations it is coming, the sensible heat, it should be same from the natural heat. Okay, so if you see, this natural heat is basically coming from Hn, which is basically the sensible heat, natural sensible heat, which is basically coming from the heat balance equations only. If you see Rn minus G minus Le, so what we get from the Hn, and if we calculate the H sensible heat separate, so that should become same. But due to the anthropogenic influence, okay, so this H is more than the Hn. And once this is the formula which is given by the Susikato and Igamachi, it is a very, this is the first level of paper which we studied. This is over the Japan, and we found his equations which we use for the first time in India. Okay, and this is the equations which is coming and which is separating the anthropogenic heat fluxes from the normal sensible heat fluxes. Okay, so H minus Hn what we did, and we got the anthropogenic heat flux. So that is what we calculated. Okay, over this one equation. So for these equations, there is so many meteorological parameters is also required, and ground situational data sets also it's required to find out these equations, and the final outputs, which basically the urban anthropogenic heat flux which will come out. And this is how the results, which is also similar patterns which we found over the urban area, which is a very high heat flux, mostly over the built up. Okay, so if you see, this is a built up area, this is grown from 51 winter also we found a similar patterns over the build-up, okay, like how the anthropometric range is actually increased. And we validated these results with this particular literature review, okay, so that we did over the similar range we found is basically it is coming the range between 200 minus 200 to plus 200. So and this our value is also falling in the same, so which is basically the validating our results over this anthropometric heat fluxes. Okay, so now this effects we try to understand with the another part, okay, scenario. So before that, if you see, this is what I just explained you about the different land use land cover classifications, which is focused over the vegetation, water body built up, and agriculture and plantations. We found the built up have a significant number of increase in anthropometric heat fluxes also, okay. Now, there is another study which we try to understand from the groundwater data sets which we collected from the field. Okay, so to make it in a similar platform, so because the ground data sets which we collected and LST which will be different. So what we did, we are whatever the groundwater we are collecting, okay, so we did the interpolations, okay, at the same scale. We first extracted the LST value from the satellite images, and then of this particular year, because we have the ground data sets of that collected ground data sets of this particular 2009 data. So that's why we focused over this particular year data sets, okay. So the same year we will collect the our LST, and we extracted the value where we collected the GWT, okay. And the same areas we extract the LST, and we created with the interpolations, we created in the same scale, we created the two images, and we found a very significant relations, not only in the images as well as in the relationships curve also. So if you found, so most of the time we talk about the northeastern and western part, so which is in a Bangalore, which is a huge change in a built up, and the similar scenario we will found over the GWT, and LST is also showing the similar kind of scenarios, okay. So this is on based on the LA. Sorry, this is anthropometric heat fluxes, okay. So sorry, first study we did over the anthropometric fluxes, okay. So anthropometric heat fluxes, if you see the same area which is showing is a high temperature zone, so that is also similar we found over in a groundwater temperature scenarios. And then we try to correlate the value. Okay, so if you see the graph is also like a similar pattern. Okay, like high, dip, and peak will almost match over the groundwater and the anthropometric fluxes. And so for the better is there is any relationships which you found over here, so that we find out the correlations curve. Okay, so the correlationships is coming almost 0.8. So very highly correlated correlationships which you found between the groundwater and anthropometric flux. So it is a very good way to study also for the urban hinterland. Okay, so that means then we start understanding about the data. Is it affecting the surface? Yes, like we why if you see these areas, those are areas are mostly the built-ups. As I told you, the unplanned built-ups is increased. So the more the concrete area, so areas which are under the concrete bodies, okay, so those areas the groundwater temperature is showing a significant higher than the other areas. Okay, so that is some kind of conduction method of the thermal properties, which is actually trying to affecting those areas underground waters. Okay, so that is why we found a little high temperature than the other areas in this particular place. So this is the one important study we found out. Okay, so the similar we will try to understand with the LST values also is almost a kind of a match. It's the similar pattern we found from the LSTs also and GWTs. Okay, but obviously there is like so many wells are there. Okay, so that is also main we have to understand. We have to fix a particular groundwater depth we consider for this particular studies. Okay, so we beyond this depth only we calculate this particular GWTs. Okay, and that is also we found with the LST also we found a significant number of you can say the correlations with the LST. Okay, so it is basically almost 0.83 which is coming up. Okay, so which is proof of our actually study there is some kind of effect which we'll found out from the unplanned built up which is grown in the Bangalore, and that is somehow it is affecting the underground. Not only it is affecting the anthropometric heat which is coming in the atmosphere and it is heated, it is also affecting the subsurface. Okay, so that is the both kind of studies which we did. And to understand this built up surface areas are more, okay, so in particular which region, okay, so for that we did this particular study over the NDBI, okay, so built up area access, and from that we will estimate more better way, that is basically the BUAI, okay, so which is basically the subtractions from NDBI to the NDVI, okay, so then we get this BUAI, okay, so and this is also the significant area which where it is showing the very high changes over this, and we found this is the area which I showed you in the previous slide also, that lake area, how it was hugely changed from this particular built up, and area is actually grown near to these particular lakes. Now, to understand the spatio-temporal changes, okay, so for that we focused more on continuous data sets, which is very easier to focus over the MODIS, but obviously MODIS resolution is quite big because of the coarser resolution image, but it is like we concentrated on this the land use land cover, if you've seen. So the area which will be more bigger concentrations of all this, like agriculture or LST or water or built up, which will be the higher area. Okay, so those areas we concentrate. We take the using the GPS, we collected those locations. Okay, and then we try to create a spatiotemporal curves over those areas. Okay, and we found here also a significant change in the you can say the built up area surface temperature increment. Okay, so that is what it is found out very clearly. Yeah, this MODIS the temperature is also showing high because of this coarse resolutions. Okay, over the winter it is showing little high value, but the pattern, if you see, okay, so that other it is not changed much. Okay, it's similar, but if you concentrate over this, okay, it's a huge change, okay, which we found over this means which is coming from 2014. If you see, there's a huge change in temperature which is increasing, and this is what it is coming out from that. Like if you see after 2014, there is a like so many government policies which is came out, okay, and which is influenced more over the industrial growth. Okay, so that is how it is somehow affecting over the environment also, which is results which is coming out from the scenario. So now this is almost we come down to the conclusions. Okay, so this is basically if you found the spatial changes of land use land cover, okay, in the maximum rate, if you found say from 7.61%, which is increased to 25.64%, okay, in 2017. And we have the 17 years this period. Okay, if you see that change, it means trained in a LST, which was actually attributed to growth more over the build-ups, okay, and resulting the surge in the population. So as the population is increased because of the industrial focused and government policies, okay, so due to that reason, the population is boomed in this particular area. If you we also did one study which I not included in the slides, that is basically the census, how much it is an increase. So that is also showing the significant increase in 2014. Okay, so which is come out from this scenario. So okay, and then see that's LST increase almost plus minus 2 degree. So it's a huge impact over those areas. Okay, and then anthropogenic heat fluxes also, if you see, it is also showing the similar increment than the summer and winter both times which we did the study, and we found a significant high over the 1999 to 2017 over these scenarios. Okay, and the groundwater heat flux as with the groundwater and anthropogenic heat, we found a very good correlationships which come with the study 0.82, and if you see the LST also, we found a very good correlationships almost 0.83. Okay, so this is how we make conclusions. It is just two are very important parameter to understand the scenarios. Okay, now there is the extracted these anthropogenic heat fluxes from the urban footprints. Okay, so that's what is very important to understand the study and scenarios. Okay, if you see basically the anthropogenic heats is a very important parameter, and it having a important effect over the subsurface, and mostly the built up where there is a conductions which is actually basically hitting the subsurface. Okay, and somehow it is affecting the groundwater areas, which is we found found mostly the areas which is covered with the concrete. Okay, so those are showing high temperature than the other, like rural and other, you can say the agriculture. So that is showing the low temperature than the this areas. Okay, so this is what we come out from the scenarios. So this paper we were published almost into two different journals. One is under review and already to publish on this particular work.